Today's lesson will be about using this manual machine, and we'll have an idea what's the material removal rate. Material removal rate. So if we understand it here, that will be a lot easier to understand what's going on with the CNC. Okay, so that's the idea. Now, this might not be the right tool for it. I'll get the right tool, but I can take this guy out and I'll buy something in here. So this guy got damaged.
Maybe out there.
There was a box in here. Okay, so this guy might do it. Okay, so we'll probably take this guy here. Yeah, that will do it. So we're gonna go ahead and I need an Allen wrench. There's the Allen wrench right there. Oh, it's right here. But there is a lot of tools in this shop. You just have to find where they're located. But so what we're doing right now is basically tightening this guy in position. All right. And then so this is kind of like, coming straight. Technically, this should, come at an angle like that and machine whatever you need it to machine. This is going to give us like, a taper. So that's not really the right tool. But I just want to make a quick setup here that would help us understand how much material you should remove per pass. So your insert is right on that tip, and you don't want to leave anything in here because they could just like, get everything off the machine. Don't leave here anything because you don't want that going into the spindle and turning into a bullet and come and hit you, okay? So this guy looks like it's going too fast, so I can slow it down with this guy right here. It says RPM, so I could make this like really, really, really slow, and then I could remove the material at whatever rate I want. And this has a coolant also, so you basically, I don't know, for some reason I might not have. I ran out of coolant. I need to fill it anyway, but look like milk. Well, there's machines over there, they already have that. Now, what I do is look, when you look at this face right here, it's kind of like dancing. This was like as cut. We cut it with what? With a band saw. It was as cut. That's why when we set up on Mastercam and we put about 50,000 on the front of the pot, it's just because we want to clean up this like, uneven cut. So we could make a really nice, smooth finish. Okay? So you always, when you set up on Mastercam, you could put 50,000, it could be 100,000, it's up to you, but for me, I typically put about 50,000, that's good enough, okay? And basically come and cut that 50,000 on the front to bring it to the exactly zero position, okay? So today, I'm gonna go ahead and just like say, all right, so when I come here and I get close, this guy is dancing, So, all right, so we're gonna go ahead, it barely touched it. I'm gonna go ahead and zero this guy. This is movement on, let's say, look, this guy, this is what, if we assume this is the Z-axis and that's the X-axis, so that we could match them with the CNC machine. So along the spindle what? Center, we always call that Z-axis in machining, okay? That's considered Z-axis. So I'm gonna go ahead and call that also Z-axis. And then the one that is going up and down is the X-axis. This is on a manual lathe. Same thing on the CNC axis, okay? Now, you can see my X-axis value, if I move this guy, doesn't change. What changes is the Z-axis because I'm only changing the Z-axis direction. Now let's say I want to remove about 40,000. All I have to do is rotate this guy and about, how much is that? That's right there, that's 10,000. Okay, that's just 10,000. So if I want to go 40,000, I just have to go right there. So why am I doing this? I'm doing it manually. I'm using this handle to crank to whatever dimension. This is a digital readout. Okay, there is a calibrated digital readout right there, which is this guy right here, and there is for the Z-axis, there is another one in the back. But anyway, that's how you're getting those values, okay? Now, this is like 40,000 at a time, and let's see what this does. And I could move it manually, or I could make it, you know, semi-automatic. This handle right here. Okay. And there we go. Look at that guy, it's moving. This is kind of like, you know, semi-automatic. It's really, really slow, but I could speed it up, okay? The reason I'm moving too slow is because I don't want to, let's just go ahead and move this a little closer, about right there. And now we're going to start up. And if we make like really, really bad noise, I'm going to step on the brake. That's really nice, smooth. I'm going to stop it. The reason I want to stop it is because I don't have a coolant that guy could really get hot quick and break the insert. But that's basically, you know, 40,000 is not that bad. And actually that's about the right number to remove hair pass. When you're doing machining on CNC, you want to be as close as to the nose radius of your tool tip, okay? So this, you know, you can see it's like really nice. Maybe some of you can see it from far out there. It's like really nice, smooth finish, right? Look like a mirror finish, right? Yeah. So, I mean, you could basically, now with this guy, I didn't have the coolant turned on because I forgot to fill the machine with the coolant. I could have machined it even further in. So about 40,000, 50,000, sometimes you can push it close to 60 on what? On stainless steel, but that's a little pushing it, okay? Because a lot of the tool nose radius is about, you know, it's like from 15 all the way to 60 something. So that always your tool nose radius and your amount of material removing, if they're about equivalent, you're okay. Now your feed rate, like, you know, the feed rate I just used, which is a semi-automatic this way, you got to slow on that, okay? So you have to come up with a combination of the tool nose radius, the feed rate, and your spindle speed guide. Then that will give you, instead of a continual string of chip, it would give you like, broken chips, like really pieces, and that's what you want usually, right? Because if they are like a string of it, what happened? They entangle on the spindle. Before you know it, they go ahead and grab the tool, and they all are like glued together, and then they break, and you're gonna have a mess on your machine. So typically, you have to make sure we come up with a combination of tool radius is always given, your spindle speed, and the feed rate.
So the more high speed is the less longer of the chip.
Well, not necessarily, not always the case.
What are the combinations?
Well, this is kind of like usually you could get it from the insert manufacturer. They would tell you what speed you should ride it, what feed rate, and then you put those input in your machine and you give it a try. If your chips are breaking into pieces, you got to process.
So it's just by trial and error?
It's kind of trial and error, yes. Sometimes it's trial and error, okay? But if you read more about it online, you will get the idea of what I'm talking about here. All right. So anyway, that is basically today to show you how to use this machine. It wasn't that bad, you set it up, and you turn the OD to whatever dimension you want. Your digital readout is going to help you. But let's say you don't have the digital readout. You got some graduated dimensions here you could use to also get whatever you need. But this is a little crud, it's not that good, because here you are like, trying to rotate this to the right dimension, but the digital readout is a piece of cake, easy, okay? So that was the idea for today.
So the digital one, the alternative of that?
The digital readout is kind of like, a lot more accurate, because this is calibrated. This is also calibrated, it's accurate.
Oh, okay.
It's just like, you're using your human skill and eyes combination and just moving. Sometimes you might have
they
a
do the
slot.
same job.
Huh? They do the same job,
okay.
That's right. They do the same job. But on this guy, you got a slot. See this guy right now? Look, I'm rotating this, but nothing is moving here, right?
Okay.
So you have to go basically, all right, and now I'm moving, look. Now the minute I start moving, I have to just count here. All right, so the digital readout makes life a lot simpler and easier, okay? But anyway, so that's how you machine, like I said, the coolant, I wish it was there. We had it filled up, and then we could have machined this part a lot further rather than just stopping.
Does it long time?
Huh?
I mean, filling up, does it take long? Why don't we try?
No, it doesn't. It doesn't. Like I said, today it was nothing, but I just want to tell you about amount of cut you take per pass.
Because I want to see the Z and X axis.
You want to see both? Well, this is not the right tool. We will have to find the right tool. That is pretty much this guy. Well, this is left. Here you go. This is also left. So which means you have to put it this way. And I don't know. Yeah, this is okay. So you could put it this way. And this is, you can see the tool is already chipped, so I could take this guy out, and there is another one over here. So these guys, the people that I bought this stuff from, they were beating them up like crazy. This is all left. See this guy right here? This one is the right. But what they did was they machined these, and it's just too skinny, so it will get in here. You just have to kind of adjust it up and down. And you could use those screws to move to the center of the pot. You always have to be right at the center of the OD. If you're slightly down or up, then you're just overworking your tool and it's not going to machine that smooth. What time is it, sir? Okay. All right. So anyway, that was the idea, and what I was trying to teach you today on this machine was nothing but, hey, this is manual. You can machine stuff here. It just takes a lot of your labor, a lot of your involvement, meaning you have to move stuff, you have to adjust stuff, you have to check stuff. With the CNC, that is kind of minimized. You're not working with the CNC. The machine is working, not you, okay? Maybe you work when you set up your stock and your tool tips, their position. Other than that, you don't do much on that. But on manual, you're here basically moving back and forth, checking the dimension, changing the tools. Of course, over there, once you put the tool, maybe you might change the insert if it gets worn out. But other than that, you're relatively safe. Okay, so then there is like so many other knobs you do over here, but today on this machine I just wanted to show you it's running and it's cutting and how much material you could remove per pass. Typically on a lot of stainless steel, between 30,000 to 40,000 is an acceptable value.
So can you summarize all the sticks, what they do?
Oh, okay. All right, so we're gonna start over here. Of course, for this machine, you switch the power in the back. You turn it on. This is right now on neutral. Now I could be on the high speed, which is from 165 RPM all the way to 2,200 RPM. Or I could be on the slow side gear over here, which is from 30 to 405. There is, of course, a little overlap here. But this is the high speed and this is the low speed gear. This machine has gears inside, okay? So basically this it changes to the different gears. Same thing like with your automatic transmission, like they have different gears. This is a machine that has a gear inside and you just switch to the, if you want to go really, really high RPM, you just have to go to this side. If you don't want to go anywhere, basically this is neutral and this guy is like rotates a lot easier because it's on neutral. But the minute I put it here, this is a lot slightly heavier because the gears are engaged, okay? Now, I'm gonna be on the low side. Now you got these two that shows you direction B, lathe, there is A and B. This tells you the direction. When I feed, the feed rate direction, not rate, but the feed direction, okay? So this guy, the feed is that way, and the guy up is feeding this way, okay? Now if we turn on the machine, it is on. It's just except we're on the slow side. Okay, so I need to ramp up the, look, this RPM is going up. So that is basically how you increase your RPM. I can stop this, go to the high side, and then when I turn it, it's going to be like really, really high RPM. Anyway, so this guy, right now, the feed is in this direction. So when I come over here, and I say, hey, I lift it up, this guy. Let's feed it this way right now. So like over here you say, lathe stop to change, stop lathe to change. What I just did was, and that's not a good thing to do. Okay, so you have to make sure your lathe is first. In order to change this, you just have to stop your lathe first, okay? Anyway, so right now I'm at direction B, and then I have A. Remember, there is a lot of numbers here with different letters. Look, A, B, A, and then you have C1, C2, all that, a combination, and D. Like over here, C, E, F, G, H. A combination of all these, you could do some kind of like threading. And if I just keep talking here, this guy is going to come all the way and start machining stuff, okay? Anyway, so that's direction this way. If I want to go the other direction, I have to stop my lathe. That's, by the way, the brake. And then I can change this guy about right here. And this is something is not like, here we go. All right. Because remember I said, what did I say? They're gears. So if the gears are not really lined up right, they could, do some whatever. Look at the machine. It's going that way right now. Why? Because I changed the direction. So these knobs this handle right here, it has an arrow on them. So it tells you, move that way or this way, depending on which location you're at. Okay? We got that idea. We already know what this is. This is basically on which RPM do you want to really run. So I can stop this guy and also stop your machine when you change here. Right now, if I go, it's going to go like crazy. See, that's like really, really high RPM. This is, it says RPM, so this is basically how you adjust your speed. I can go really crazy. This is 600. Okay, so this guy could go all the way to 2,200, but you don't want to run anything in that range. It's not safe for you because this is all open. Usually you want to run, this is good speed. I don't want to run anything higher than 1,000. If you go to 1,000, look what 1,000 is. Would you feel really comfortable running here? I don't think so. Okay? So always keep your RPM to a level where it's like, manageable, relatively safe. You're not in a hurry. So when you're working with manual lathe, you gotta make sure your RPM is not really high, because if something, a chip entangles or something, it can just grab you and cut your finger or stuff like that. So always run on an RPM that's a lot safer and slower.
So which number is set, you say?
Oh, to me, I wouldn't have a problem running it at this RPM. This is good. This is like, it's your comfortable level. But to me, this is good. This is all right. This is all right. This is okay. Yeah, this is okay. But here, that's not good. That's a little too high, because you could hear from the noise.
So till 500 is okay.
Yeah, about 500 is okay, but again, it all depends. If you're really expert on this stuff, maybe 1,000 is okay for you. But if you're a beginner, you better be around 200 RPM, maybe 300. Don't go higher than that until you feel comfortable. Okay. So it's a matter of your experience and how comfortable you feel. Okay. And then the other thing is the chips. Are they breaking, or are they like really long, kind of like a string? If it's a string, you better slow down. There is another safety. This guy right here goes in here. Whoops. Somehow. Alright. So this guy goes in here. There you go. So this is kind of to an extent protects you from flying chips and coolant and all that. You could put this one here, and you're all right. Okay. So that's what is bad about manual lathe. Don't be too scared, because you're a machinist. You're doing stuff day in, day out. This machine is up to you to adjust to whatever speed you want. So it's not that big of a deal, but you got to be able to handle them right to stay safe, because you're working on an open machine where things are flying, and chips. All right, so we're done with this, done with that. This is an emergency stop. Let's say I'm running this machine, and all of a sudden something is like, entangled. Usually you stop right here, so you can reach this guy and just, that's it. It would just stop it. But instead of doing that, why not just stop on the brake? Your brake is right here. And in fact, it's a lot safer because you're out of the way. So you basically, so this is your brake right here. So you got multiple options. Maybe you were on this side of the thing while you were running. You could stop this guy. Rather than going over there and trying to get on the way, I could stop from this side, and that's another way of stopping it. Okay? This is a coolant on and off. You can see like a faucet here. So this is automatic, and this is, so that's the coolant. This guy right here, the RPM, like I showed you, this is the different type, I think for the threading, you just have to be aware, and also number combination. This is kind of like the feed rate, what gear. But anyway, that is, and this is the digital readout. This is the spindle. Okay, and this is a tailstock. And this is basically your carriage where it holds the tool. And this is the type of tool holder, and you got, this is kind of like, you release this guy, take it out, quick change, like, and that over there, you got a bunch of screws you have to take out before you can remove it. But
What does it do, this one?
This also is kind of like the same thing. I can only move this guy, like, it's moving. forward. It's a little stuck because maybe need a little cleaning. So it's the same like this guy right here. But this guy, when I move this, nothing moves in the okay, so when I move this guy, nothing changes there, look. Because I'm only moving this guy right here, is sliding. But this guy, it does move, and this guy, oops, and this guy moves back and forth. So these are, this is the automatic feed. If you want to move only in the Z-axis, you move this guy up. Depending on which direction is selected, it might go that way or this way. So up for this guy is to move this guy this way or that way. How? Depending on which is selected. If I selected the lower one, it goes that way. When that is up, it only moves that way. If I move this guy up, and this is also up, it will move this way. So that's your feeding into your part. All right. Okay.
And then this part.
Okay, and then we have this guy also. So I could also move this guy up and then move this guy down. This will move this guy this way, which is the x-axis movement. This is down. So this guy right here serves both the x-axis and z-axis. If it's down, say move that way. If it's up, it's moving this way. And this guy has to be up, engaged, okay? All right, and this is, oops, and this is nothing but to start the machine. You click it down, you hear click there, and then up, and it's running, okay? And then this is your brake. Your brake is right here, kind of like an emergency. It's not an emergency stop, you just want to stop. Okay, so you press on this guy right here. And then also, I can click right here and go down, and the machine moves that way. By the way, I need to switch the wires because down I should move forward this way, okay? But the guy that was fixing the machine, he switched the wires or something happened, I guess. And right now the machine is moving in the reverse direction in relation to this handle. This handle, when I move it down, this guy should move this way. So all I have to do is switch one of the wires in the back, two of them, switch them, and then this will move in the right direction. When I press down, instead of moving forward, backward or reverse, it will move forward, okay? Because it's kind of like, when I say lift this guy up and I push down, this guy I want it to move this way. That kind of makes sense. It's down, moving this way. Up, move us that way. That makes sense, right? But right now it's reversed. Look, when I move up, it's moving this way. It's reversed, okay? So that is a piece of cake. There is a couple wires in the back. I just have to switch them, and that solves that problem, okay? This is the tail.
The movement of this spin also helps you protect yourself from the flying chips, yeah.
Well,
if it is moving that way, the chips will be flying this way.
That's correct, but there are instances where you have to move also that way. Your spindle just doesn't move forward all the time. There will be, depending on the direction of your tool, it might be also reversed, okay? The tip itself. If the machining goes better the opposite direction, then, go the other way, okay? But anyway, in terms of the chips, if they go the backward, it's okay, it's going to go on the other side. If they move forward, they come on this side. But remember, when I'm saying chips, is like they fly out. Why? Because you had your spindle really too high. Okay? Other than that, they're supposed to fall here. They actually pile up here, and you just remove them, put them in a recycling bin. So typically they're supposed to be here, not flying out, going all over the place, unless your spindle speed is really, really high. All right, so this is the tail stock. For the tail stock, if you want to drill something, you just put this guy in here. Well, that's not the correct one. And I can insert this guy over here. Okay, so I could put here and then put a drill bit in here. Slide this guy forward. And this guy comes about right here. Get this guy out of the way. Look what I'm doing. I'm working too hard, right? This is like, moving stuff. That's why it's not CNC. Get this guy out of the way. And with the drill bit in here, lock it in position. And then all you have to do is basically this guy moves out. See that? And that's how you make a hole. You drill a hole. This is all manual. Too much work, right?
Yeah.
All right. Huh?
Only to do one at a time?
One drill at a time. That's correct. Again, this is the thing. This is manual. What else do you have to do here? You just, making parts. You take your sweet time, and so you're gonna do one at a time. You want to speed up stuff, you take them to the CNC, and you better be making a lot of parts, because the CNC, is typically designed for mass production, not for like, a couple or 3 or 10, Okay, so I think that completes the lesson for this manual machine. Any questions here?
So this works only just scratching, getting holes, not the, let's say, the grooves. You can make grooves.
I can make grooves because all I have to do is just get the right tool to do the grooving, but can I create profiles on the face? No, I can't. You're right. This is just turning the OD, turning the ID, facing off, face operation. Remember on the CNC we were on Mastercam, we were saying face, so you just get a tool and it's going to just face the face, clean up the face really nice, turn the OD, drill a hole, and then you can open up the ID by just getting another tool that basically open up the ID. So this is all turning, okay? You can turn the OD, make it smaller. You can open up the ID, make it bigger. You can face the front. That's all you can do on this manual lathe, nothing else. Yes? Yes, I can make grooves also, because all I have to do... Yes, you have to change the type of tool that was going to be, that will mimic your groove, okay? So you basically, cut and then take it out and then cut another. That's how you can make grooves, okay? All right, so what was the lesson in here today? Just kind of to familiarize yourself how this manual lathe machine works, but also the important that we're going to take out of this manual lathe is nothing but the material removal or per pass. For every pass, how much do you remove for a lot of the different materials? And my description was make sure it's kind of comparable to your tool nose radius. If it's 30,000, remove about 30,000, you're safe, okay? At least in that neighborhood. If it's 40,000, you could possibly remove about 40,000, you're all right. Maybe 30-something, 40, okay? If you're not in a hurry, be always on the little amount, because you don't want to overwork it. The tool nose radius, if it's about the same size, chances are there is too much, force applying to remove the material, then it might just snap, it might break on you, okay? So always.
Which one is bad for the tool? The more removal or less removal?
More removal is bad for the tool, because the entire nose radius is basically removed, like and just too much force, and it gets hot, and it could just snap right there. If I only remove like 10,000 on a 40, on a 30,000, it's too skinny. The tool will last a lot longer, because you're only removing a little material, right? But your process takes a lot longer to finish the part. Okay, so that is kind of like give and take kind of thing. You want to finish the part quick, but you're gonna also break your tool relative. It will get consumed a lot faster, meaning its service life would be a lot shorter. But at the same time, if you have the time, might as well just remove little amount and let your CNC does all the work. So the reason we came to this manual lathe today is just kind of have an idea. But one thing, it was the material removal rate. So on here we removed 40,000, and the thing looks like really nice and smooth. And by the way, the speed of the spindle was a lot lower. When I go over there on the CNCs, it will be a lot faster, so it would be a piece of cake, okay? All right, now let's go to the CNC.